Let me give you a little bit about myself. I'm Steve Loper, the VP of Engineering here at Scale. I've been wrangling code and engineers for my entire career. I spent about 20 years doing consulting and custom software development, and 20 years is more than enough consulting for any one person. After that, more recently, I spent 7 years running an engineering team doing SaaS accounts receivable. After that, I took some time off, and then my friend Scott convinced me to come do some consulting with this cool company he had called Scale Computing. And I didn't know it at the time, but it was just a ploy to get me here as a full-time employee, and it worked. So I've been here about 2 years, and it's one of the best decisions I've ever made. So I'm here today to talk about SC platform and security. So first of all, why is security important? Other than Marlena really wanted me to do this talk, and she can be pretty persuasive, why am I up here to talk about security today? Well, really, it depends on your industry, your customer segments, and a bunch of different things about how security really matters to you. And it will widely be dependent on who you ask as to why security is important. So the first thing I did, you'll notice AI is a big theme here this week at Scale. At Platform, I asked AI, why is security important? AI gave me these 7 things, so I'm going to go through them and see what we think here. So the first one said, protects sensitive and valuable data. I didn't give AI a very good grade for this one. I thought, this is pretty obvious. Maintains business continuity. Okay, that's pretty important. I think we all want our businesses to be here tomorrow and the next day. So yeah, that's a pretty good reason to care about security. Preserves trust and reputation. Our reputation is is crucial to our business. If Scale didn't have the reputation as having world-class customer service and a rock-solid platform that's easy to maintain and run, you all wouldn't be here today. So we want to make sure we maintain our reputation. We want to make sure that you maintain your reputation, that whenever somebody goes to Royal Farms, that chicken is fried and ready to go. Ensures compliance with laws and regulations. All of us are dealing with an ever-increasing set of regulations. If you're a global company like Scale is, you have multiple jurisdictions that you're dealing with regulations in. And so this is pretty important. Prevents financial loss. None of us want to lose our money. None of our companies want to lose our money. We don't want to see our clients lose money. So this seems hugely important. Reduces risks of cyber attacks. This again seemed kind of obvious to me. Thanks AI, security is so we're not insecure. So I wasn't very impressed with that one. And then the final one, protecting employees and individuals. I thought this was a pretty good one. A lot of times when you look at cybersecurity and why it's important, we're not necessarily thinking about the people that are impacted. When you look at that, that starts with, I'd say it starts with maybe the IT employees who have to, battle back from the cyber attack and try to establish, systems as normal. Then it could be the customers who were impacted by that attack, whether your service was unavailable, God forbid some of their personal information was stolen, so that individual personal aspect of a cyber attack is pretty important. Okay, so that's what AI said. Now today, you're going to see for the first time Steve's 3 R's of security. Why does security matter? First one is resources. In 2024, security incidents cost $9.5 trillion. That includes direct losses, business impact, lost revenue, fines, things like that. That boils down to 4.88 million per incident. That's up 10% since Craig gave the number last year. And that represents 8 months of human effort per incident. So, that's just huge. And if you look at a small IT group like the Royal Farms guys, that's 4 months of their lives. Next one, reputation. 66% of consumers are inclined to distrust a company after an event. When we go to that personal impact, it's even worse. 75% would consider cutting ties altogether if they were personally impacted. So that person who is personally impacted, who gets that letter and says, your information may have been exposed, that person, 75% of those people are going to consider, should I continue to do business with this company? And then the last R on my list is regulatory responsibility. Regulation, as I said before, is inevitable, especially for enterprise businesses, and Scale is providing a best-in-class security architecture to meet those regulations. We'll go over that in more detail later. So let me talk about secure by design and how all of SC platform is secure by design. I'm going to start with Hypercore. Hypercore exemplifies the concept of secure by design in its integrated HCI model. This differs from traditional configurations with separate components. A lot of you are familiar with these, such as the 3-2-1 model, where you have a separate management server and multiple hosts connected to a SAN or NAS. Those systems are much more susceptible to network attacks, such as man-in-the-middle, because of just the nature of having those multiple components and having to get the configuration correct across all of them. It's just more complicated to set up. In contrast, Hypercore integrates web-based management directly into the system, so you have one point of configuration to create a secure, self-contained appliance. It not only removes potential attack surfaces, but it also simplifies the architecture, significantly lowering the risk of unauthorized access. Hypercore's design philosophy is fundamentally different. We control the entire stack from top to bottom, ensuring that when patches are released, they're applied across the system simultaneously. The entire stack is tested by my engineering and QE teams before it's released, before it's given out to you, which provides our users with the confidence to deploy them in multiple production environments simultaneously. This is in contrast to when you have these multiple systems, each shipping out their own patches. You never know when patch from vendor A is going to mismatch with patch from vendor B, and you're on two different support lines trying to figure out who can help you fix it. Another part of our secure by design is snapshots. Backups alone are no longer sufficient. Backups are a great part of the strategy, but snapshots have an extremely important role to play. A snapshot, given its name, is a quick picture of a server, including all the files, software, and settings at a very particular point in time. Snapshots are immutable, and they change your posture against ransomware and malware because they're fundamentally resistant to attacks. That immutability means it can't be changed. And so if you have an immutable snapshot and somehow your VM gets affected with ransomware, you can immediately go to that snapshot and go back to a point in time before that ransomware was attacking you, and you're up and running. Scale can protect virtual workloads with snapshots so that you can recover in minutes in this case. Okay, we've been talking about Hypercore and the snapshots of Hypercore. Let's go to the other big piece of SC platform that you've heard a lot about this week is Fleet Manager. So our Secure by Design extends through Fleet Manager, which is our cloud-based orchestration and monitoring tool that oversees your fleet of Hypercore clusters. One of the fundamental principles of Fleet Manager is the outbound-only communication strategy. We initiate traffic from the Hypercore cluster to Fleet Manager, and we don't expose ways to come in from outside to that cluster. This outbound only communication strategy eliminates the attack surface of someone trying to pretend they're Fleet Manager coming in to the system. This approach adheres to best practices for cybersecurity by shielding your cluster from unauthorized attempts. This whole approach significantly reduces the vulnerability exposure, as there's just no gate for somebody to knock on and get in. This method of connection not only secures data in transit, but also ensures the integrity of your network. Next, I'm going to go over some security best practices with SC Platform. Throughout the year, we get a number of questions from customers and partners surrounding security. Questions like, what is the best method to authenticate to SC Platform? How do I secure the backplane? How does SC Platform fit into my enterprise logging strategy? What are the options to encrypt my data? And how important is physical security, which can matter when you're in places like on a shelf over the fryer? To answer these questions, we put together and released a security best practices for Hypercore customers. This document is available on our community site, and it contains the combined knowledge of our product and customer service teams regarding the best ways for our customers to configure and secure networks, their authentication and authorization, logging, the physical hardware, and data encryption. It's beyond the scope of this talk for me to go through that entire document, so please, if you're interested, download it. But I'm going to go through my top 3 items in this, the 3 things that I think matter most. Number 1 is for authentication and authorization, utilize our OpenIDC provider to manage access control. Most large organizations, and even today, many small organizations, use something like Microsoft or Google so they can have single sign-on. If they're following best practices and if you have sensitive systems, a lot of times you're using not just Microsoft or Google, but you're also using on top of that their ability to provide MFA or multi-factor authentication. For that reason, Scale Computing recommends that you use our OpenID Connect providers to access both Fleet Manager and the Hypercore clusters themselves. By using this single sign-on approach, you're much less likely to have users fall back to the post-it note under the keyboard method of keeping track of their passwords. I will not ask for a show of hands because I know somebody in here is doing it, but nobody will admit it. As I said before, when combined with MFA, SSO is really the best way to control authentication and authorization to your SC Platform resources. Number 2, secure the backplane. The backplane is the heart of a Scale cluster. The backplane is where all of the control information is passed between the nodes and is what keeps that high availability up and running. A compromised backplane would be a very bad news and would allow attackers access to what's going on in that cluster, and it's something that you just don't want to deal with. Whenever possible, and this isn't always possible, but whenever possible, use separate NICs and switches for that backplane so that you can tightly control who has access to the switch, who has access to that data. And you can separate it from the public-facing side of that cluster. When using separate NICs and switches isn't a possibility, backplane over VLAN is a very acceptable alternative. The reason we suggest the physical separate switch and NICs is simply because it is a simpler way to secure it. Again, we try to avoid the complexity. When you set up backplane over VLAN, then your security is configured on is dependent on how well that VLAN is configured. So if you're using that method, you just have to take a little extra time and care to make sure you're securing that VLAN and tying down that traffic. Either one of these methods, by using either one of these methods, you can protect against intrusions and ensure that sensitive data is only flowing between the nodes where it needs to be. All right, my final tip from this document has to do with out-of-band management and locking it down. Out-of-band management is provided on nearly all of the systems that we support at scale. It provides a wealth of tools that basically lets you remotely access the hardware as if you're sitting in front of it with a keyboard and mouse. OOB goes by many different trade names: Intel AMT, Supermicro IPMI, Dell's iDRAC, HPE's ILO, and Lenovo's XCC. So the best practices when using out-of-band management, which we definitely recommend, it's good in a lot of cases, but these are some of the things you need to think about. Changing default login credentials. All of these systems will come with some kind of default login. Everybody knows that default login, including people you don't want on that system. Make sure you change that. Again, network isolation. It's almost like I'm trying to sell switches here. We actually, that's not our core business. We have sold some switches, but that's not how we're trying to make our money. But this is another case. Isolate that out-of-band management on its own network and make sure that only people who need that out-of-band management have access to it. Remove unused accounts. Make sure that you aren't sharing credentials with people, and that if someone leaves your organization, you remove that out-of-band management account immediately. It's not necessarily you don't trust that person, but you don't want a login setting there that nobody is using. It's a potential for somebody to try to crack that, and you might not know it because the thing that, hey, somebody's trying to use your account might be going to an email address that no longer exists. And maintain up-to-date firmware. These systems tend to have their own firmware, and making sure that's up to date will make sure that you're not susceptible to exploits that were found and fixed years ago. All right, my next topic is regulated environments. Navigating the complex landscape of regulatory compliance is crucial for organizations in many different industries and locations. Having recently gone through our annual SOC 2 and ISO 27001 audits, ISO whatever that number is, I know the work involved. And I appreciate, by the way, there's many people on my team that helped with getting those, and Mark Smith was very crucial in getting that. So a round of applause for that group of people. But today I'm going to talk about how SC Platform aligns with these regulatory requirements through both the design principles, some of which I've already talked about, and the features it offers. Regulatory compliance is more than the mere infrastructure. It's a comprehensive framework of policies which are critical for maintaining compliance and securing sensitive data. Our platform is designed to simplify compliance by embedding it into the core architecture. We ensure that adherence to standards is not an afterthought, but it's a foundational component. Our platform organizes and meets these rigorous standards through several key features. Sorry about that. Okay, so several key features are helping us with this regulatory requirements. They include integrated security controls, data protection features such as encryption, access controls, and audit trails, policy management, enforcing those policies that are critical to securing your system and that align with the regulations themselves, and then regular updates and patching. The fact that our system, as we described earlier, that the entire system is patched and updated in a consistent manner is a big part of most of these regulations. Ultimately, the scope of regulation encompasses more than just the technology. It's a holistic approach where the policies that your company sets are as critical as the systems that enforce them. SC Platform not only meets these needs, but also supports the broader compliance goals of organizations by simplifying the integration of policy management and adherence. All right, into some specific regulations and a specific set that we get asked about quite often. The question that we hear a lot, especially from new customers and from our sales team, will be, can Hypercore be used in a PCI environment? The answer is a resounding yes. We have many customers who use Hypercore in a PCI environment today. To answer the question in more detail, my team created another document, which is also available in our community portal, about PCI DSS and best practices with Hypercore. The document lists the 6 control objectives, and for those of you that are familiar with PCI, you probably know those control objectives by heart. I've got them up here on the screen. I won't read them to you. And describes how to configure SC Platform to meet all of those objectives. There's a ton of overlap between this document and the things I went in the other document. Some things that are just best practices are also exemplified, in these control objectives. So for anyone who is in a PCI environment or is looking to bring PCI data onto their nodes, I strongly recommend downloading this document. All right. Thanks a lot.